Hello everyone, welcome to DTS Programming. My name is Daniel and today I'm presenting my graph intro project, comments and testing for my CSC382 Data Structures and Algorithms course at the University of Advancing Technology. For this course, our expectations were to either build our own graph with basic functionality including insert, find, delete, and print. Option 2, use a library and then build a graph using the functions defined within the library. At a minimum, insert, find, delete, and print. And option 3 is review graphs that have already been created. I went with option 2, so I created a graph using library to define my functions. So moving over to my program, once again I have a basic main menu. You can see my first and second options: add nodes, add edges. Third and fourth options: remove nodes, remove edges, and 5, display the graph. 6, of course, is my exit option. So what I've done is I've defined or predefined a graph of the United States, and I'll go ahead and display that. So what I have here is the 50 states in order, and I've started to add the edges, which are each connecting state. And so you can see here we have Alabama connected to Mississippi, Tennessee, Georgia, and Florida. Of course, I've been using a map. Alabama, Mississippi, Tennessee, Georgia, and Florida. Mississippi, Tennessee, Georgia, and Florida. And so I've been going through and adding the edges for each state and the connection, which are the connecting states: Arizona, California, Nevada, Utah, California, Nevada, and Utah, Colorado, New Mexico. And so what this program does, aside from showing that the graph is being constructed properly and the connections are being made properly, is this could be used as like a GPS system, or you could implement Dijkstra's shortest path to go from one state to another, traversing through each edge connection for the defined nodes. So let's go ahead and define something that hasn't had an edge value added yet. We'll go here to Alabama. Alright, so for some reason it looks like Alabama and Alaska, Arizona, Arkansas, looks like these all have duplicate values. So that gives us an opportunity to show the remove nodes and remove edges functions. Let's go take Alabama out of here. Alright, one of our Alabamas has disappeared. Alaska, Arizona, and Arkansas, we're going to take all of those out. Let's see what happens. Alright, so now our graph is correct. We only have one of these values up here. Now we can define the connections again and see if it all works out properly. We'll go with Arizona this time. California, Nevada, Utah, Colorado, and New Mexico. Okay, there you go. California, Nevada, Utah, Colorado, New Mexico. And you'll see that if you go down the list, Colorado, Arizona got added. Nevada, Arizona got added. New Mexico, Arizona got added. So it's adding both ways. When one gets added to Arizona, the other connection is made to the other defined state. And I can also remove a connection. So let's take New Mexico off Arizona just to see what that looks like. Number 4, remove edge. I define the graph so you can see which connections are already made. Let's go with Kansas and Colorado. Since it's only the one connection. Same thing, we just enter the 2 nodes, vertices, states in this case, and you see that connection was removed. So very quickly we just went through add nodes, add edges, remove nodes, remove edges, and display the graph. And now we'll go into the code where I will show where my find function actually resides and how that plays into how my program is built right now. So here in my code in my main program, what I've done is I'm just using the graph library that I created. I have a program driver class. I created an instance called program, and then here I'm calling program.mainMenu, the main menu method from my program driver class. Alright, in my program driver class, I declare a private global graph called states, and I set it equal to new graph, and this is the size value here. Then I create a private global list, a string list called nodes. My first method, the main menu method, It's just a menu that displays in a while loop. While the exit option is not selected, this menu will be displayed. Or a menu option is selected, then it will send that option to the verified menu option. Verified menu option is basically just for error checking to make sure that the menu option selected is valid. So it's going to come in here, it's going to make sure that the value selected is a number or a numeric value. If not, it's going to enter this while loop and prompt for a numeric value until the proper value is entered. Then it's going to convert all those values to int32 so that we could do this comparison here and check if the option passed in is between 1 and the exit option. If it is not, then it's going to prompt for a new option value and recursively call this check to make sure the new value is valid. Then we'll drop into call option method. The call option method is just like a switchboard here. For each case, we're going to send the program to the proper method. So for case 1, add node objects. Case 2, define edges. Then remove node objects, remove edges, and display graph. For add node objects, we're storing a value to control our while loop here. And we're storing our node value in this string here. We're checking if the yes no value equals y, which I set it initialized to y. So it's going to go into this while loop, clear the console, display what our header is for this method, add node objects. For each node in nodes, it's going to go through all the nodes in the node array, in the nodes array, and it's going to display the nodes that are currently present. And it's going to prompt for a value to add to the graph. Going to iterate through each node in the nodes array again, and while the passed in value is equal to a value that's already in the array, it's going to prompt this value already exists and ask for a new value. After that error checking, it's going to add the nodes to the nodes array, passing in the data specified by the user. Then the program is going to prompt if the user would like to add another value to the graph. So basically what this is doing is it's going through a while loop asking for node values. Those are all getting entered into a string array, and then at the end of that, once the user says they don't want to enter any more values, it's going to go into this for each loop. It's going to go through each node in that nodes array and then add the new nodes, calling this method from the graph class and passing in each node value. So this is actually creating the graph right here. For my define edges, works very much in the same manner. I'm storing two node values here. I have the same while loop setup. While the yes no equals y, clear the console, display the header, show all the values in the nodes array, prompt for the first edge connection, prompt for the second edge connection, and store those in node 1 and node 2. And then right here, we're going to call the add edges method from our graph class and pass in our defined node 1 and node 2. And then ask for another connection. Removing node is very similar to adding node, only this time when we get to this point we are calling the remove node method from the graph class. And remove edges, of course, just like add edges, except we are calling remove edges and passing in the first and second values. And then for our display, we're simply calling print graph, the print graph method from the graph class. So we will go over those graph class methods in just a second. Here we have a node class. This is just basically setting up our node with the data in it. So we have our public string data. We create a list called edges here in our node class. And then we have a node constructor, which basically just sets the node data to the passed in data. Alright, in our graph class, we create a node array called nodes, and we have a integer holding the node count, a graph constructor here with the size value passed in. Our nodes array equals new node array of the size passed in. And our node count is initialized to 0. For add new node, we create a temp array and we set it equal to the size of the nodes array length plus 1. Then we're going to iterate through the length of the nodes array, and we're going to set each temp index equal to each node index. Here we're then going to set the last value of the temp array. So temp nodes.length, which is the highest value in the temp array, and then we're going to set it equal to a new node and pass in that data that's defined by the user. We're going to increment our node count, and then our nodes array is going to be set equal to the value of our temp array with that extra node. For remove node, we're going to store a string position, which is the index. Find node data returns an index value. So we'll drop down to find node real quick. Here you can see that we pass in the data. We're going to iterate through the length of the nodes array. We're going to check if the index value is null. Then if the node's data at the current index equals the passed in data, then we're going to return that node index. Otherwise, if we don't find the data, we will return -1. So here we're just storing an index position for the passed in data. Then we create another temp array and we set it equal to the nodes array length -1. We're removing a node. And we're going to iterate through the nodes, the length of the nodes array. If the index is less than the index of the data that we're removing, we're going to set the temporary index equal to the node's index. So think about this: if the index we're deleting is 3 and we have 6 items, then 0, 1, and 2 are going to match up. 3 is going to get deleted, and so we'll go into this else if I is greater than the index that is being deleted, then the temp index -1 is equal to the remaining node's index. So we have 0, 1, 2, 3 was deleted. Now 4 becomes 4 minus 1. So 3 becomes the new 3 for temp. 5 minus 1 obviously is 4, and then 6 minus 1 is 5. So that will set the temp index order properly. Then we call delete all node edges and pass in the data. Going to delete all node edges. This is set up to delete every edge connected to that node. We're going to loop through the length of the nodes array. Then we're going to iterate through the count of the edges array, which is defined in our node class. We have an edges array, which is tracking every connection. So we have our nodes array, then we have our edges array. So we're going to go iterate through that, and we're going to check if the edge data equals the passed in data. Then we're going to remove that edge. Then we're going to set our nodes array equal to the value of our temp array minus the one node, and we're going to decrement our node count. We went through find node already because it's called from the other functions or the other methods, and like we said, that returns an index. Otherwise it returns -1 if no data is found. For add edges, again we're using find node. First we're going to store an A index for the index value for the first string passed in, the index value for the second string passed in. We're going to check to make sure that those string values do not equal -1, meaning the data was not found. Then we're going to add to the edge array for the node whose index is found and stored up here. And we're going to do the same for B. So the second value, we're adding the data of the first value as an edge into the edge array for the second value. Remove edges, very similar to add edges. We're going to store index of the first object, index of the second object, make sure those indexes do exist, and then we're going to remove from the edge array. We'll remove the second option from first option's edge array, and we'll move the first option from the second option's edge array. Otherwise, we will show that the edge does not exist. And we covered this. Delete all node edges. When a node gets deleted, all the node edges get deleted. Otherwise, you're just deleting one connection when you call remove edges. And print graph. Of course, to display the whole graph, we're going to iterate through the nodes array length. We're going to make sure that the nodes are not equal to null. The node index is not null. We're going to display the current node. Then we're going to loop through the edges count for each node, and we're going to display every edge connected to that node. And then we will write a new line, and that gives us this effect where the node is displayed, all the edges are displayed, and then it writes the next line for the next node. So that's the basic functionality of the program. Let's add a couple more here. Let's go with main. We only have one connection to main, that's New Hampshire. Now you can see Maine is New Hampshire and New Hampshire has Maine. So the expectation was to use the library to build a graph and define functions. At a minimum, insert, find, delete, and print, which I just showed all of those in my program. Insert, delete, find is part of the graph methods in order to remove proper nodes and edges, and print. We were also supposed to comment the code. As you can see, all the code has been commented out on every page, as well as test each function thoroughly, creating at least 20 nodes and 20 edges. And that is very apparent. I created 50 nodes with over 20 connections. So that is my graph intro project, comments and testing for CSC382 data structures and algorithms at the University of Advancing Technology. Thank you.